Hey Defenders, this is Doug Burks with Security Onion Solutions. I started Security Onion in 2008 to provide a free and open source platform to help you peel back the layers of your enterprise and make your adversaries cry. Today, Security Onion has been downloaded over 1.1 million times and is being used by security teams around the world for threat hunting, enterprise security monitoring, and log management. We recently released Security Onion Hybrid Hunter Beta 3. And a big feature of this release is even better support for Community ID. As you may be aware, Community ID is a way that we can correlate between different data types. Both Zeek and Suricata can natively generate Community ID values, but what about other tools that don't necessarily have that same native capability? We sponsored the development of an Elasticsearch ingest processor that can take logs coming in, and as long as they have the proper IP address and port information, then we can automatically generate those Community ID values. And that means, for example, that we can now pivot not only from Suricata alerts to Zeek logs and vice versa, but also to Sysmon logs and firewall logs and really any log that has that IP address and port information. So we've also updated our Kibana dashboards and our new Hunt interface to make better use of those Community ID values. And so that's what we're going to take a look at in this video. So I want to take a look at 3 different use cases, kind of looking at some of those different data types we talked about: Suricata alerts, Zeek logs, and Sysmon logs, and pivoting in different directions. So for the first use case, we're going to start with a Suricata alert. We're then going to pivot to Zeek logs to get additional context, and ultimately then pivot to Sysmon logs to get a look from the host-based perspective. So in order to do that, let's go over to our new Hunt interface. This is built into Security Onion Hybrid Hunter Beta 3. And what we can do is we can click this drop-down box for the search bar and go down to NIDS alerts. And that's going to show us all of our network-based IDS alerts coming out of Suricata. So I could look through this list for interesting alerts, and one that I might find interesting might be this last one here. It's from the Emerging Threats rule set. It's in the policy category, and it's for a Windows executable being served from Amazon S3. So if I wanted to investigate that, I might click the plus sign here, and that's going to update the rest of the page. And you can see at the bottom that I have that one particular alert, and I can drill into the alert and take a look at all of the fields included in that alert. And because this is an IDS alert, of course, we do have a little bit of payload that's included in that alert, and so we can see things like the MZ file header. Because this is a Windows executable, we can see this program cannot be run in DOS mode. But this really only shows the response coming back from the web server. That's all that's included in the payload inside of that network-based IDS alert. So this is only going to give us a very small snapshot of what actually happened. So if we were to do a more complete investigation, we might want to see what was it that caused that web server to respond with that Windows executable. And so in order to do that, we might want to cast a wider net. We might want to do some data expansion, try to find other logs related to this particular TCP stream. And so we can use the Community ID value to do that for us. And we've included that Community ID value as one of the default fields here in the events table. So if I want to search for all of the logs that contain that Community ID value, I can click the plus sign here, and that's going to add Community ID to my search, but I'm still filtered to just looking for alerts. So let me remove that part of the search and run it again. And so now we're looking at all of our logs that match this particular community ID. And you can see there immediately that we have not just one IDS alert that matches that community ID for that particular TCP/IP stream, but we have 3 different alerts. So here's the one that we knew about. This is what started our investigation. Then we have this one, which is also looking for Windows EXEs. It's just a little bit more broad because it's not specifically looking for EXEs being downloaded from Amazon. This could be downloaded from anywhere. And then finally, this one says that somewhere in that TCP stream there was a user agent string that reported to be curl. Now this might be a legitimate curl binary, or it could be some other binary that's spoofing a user agent. So immediately, just by pivoting on the community ID value, we get a little bit more context just looking at the IDS alerts themselves. But if we look at this events table at the bottom, we see that there are other data types as well. So in addition to the 3 alerts that we just looked at, we also have some Zeek logs. So we've got the Zeek connection log, we've got the Zeek HTTP log, and then we've got an endpoint log coming from Sysmon down here at the bottom. So let's start by looking at our Zeek con log. Of course, in the connection log, we see things like GeoIP information. We see kind of abstract information about the number of bytes, number of packets in that particular stream. So some good additional context there. But then I might want to next go to the Zeek HTTP log. So let me drill into that one. And here's where we can see a little bit more about the request itself that generated that web server response. So we can see the user agent string that was curl, and that's what generated one of the other IDS alerts that we saw. We can see that http.useragent here. We can see the virtual host field. That's the website that the user actually went to. In this case, it's testmynids.org. And the URI is the actual file name that was requested. So the full path would have been testmynids.org/exe/calc.exe. So this gives us a little bit more information. And again, very quick and easy. All we did was pivot on community ID and we get alerts and Zeek logs. But now let's see if there's even more context that we can get looking from the host-based perspective. So this last log down here comes from Sysmon. So if I drill into it, one of the really nice fields that we have here coming from Sysmon is process.executable. So this is going to tell us the exact process that generated that particular traffic flow. And so now, again, you see instantly that we're able to pivot starting from an IDS alert, moving to Zeek logs, moving ultimately to the endpoint itself and pinpointing the actual process running on that endpoint that generated that traffic flow. And then of course, because we have full packet capture, if you wanted to see the full TCP stream from start to finish, you could click this PCAP arrow, that spawns a new tab. We go out and get the full packet capture, extract the stream, and then render that as an ASCII transcript. And again, we see the host header of testmynids.org. The user was requesting /exe/calc.exe, and then the web server responded with that particular Windows executable. So again, very quick and easy demonstration of the power of community ID and having all of these different data types at your fingertips. So that's kind of use case number 1, and that was starting from an IDS alert. Now, if you're dealing with sophisticated adversaries, they're going to be quite good at evading your IDS rules. And so you may not have any IDS alerts whatsoever. And that's kind of where hunting comes into play. We might want to go on a hunting trip through our logs, looking for signs of compromise without necessarily starting from IDS alerts. And so this is going to be use case number 2. For this one, we're going to do some very simple, very basic hunting. We're going to click this drop-down arrow. We're going to go down this list, and we're going to look for our Zeek HTTP logs, and we're going to group by user agent. So we're going to stack on the user agent field. This is always a fun kind of thing to do in an enterprise situation because your typical normal user agent strings are going to bubble up to the top. So things like the Google Chrome user agent, the Firefox user agent, whatever normal typical web browsers you have in your enterprise are going to bubble up to the top of this list. But then when we eliminate those normal things that bubble up to the top and start looking towards kind of the long tail of this group by, that's when we start to see those anomalies. That's when we start to see those things that stand out and are worthy of investigation. So for example, we might see things like Black Sun and say, what is that? I've never heard of a user agent called Black Sun. Likewise, Jedi VCL. That doesn't strike me as being any legitimate user agent string that I'm aware of. So I might want to click the plus sign and filter down to that particular user agent string. So now I can drill into that particular log and see the individual fields within the log. And we can see again that this is somebody going out to testmynids.org with a user agent string of Jedi-VCL. And so this is coming from the Zeek HTTP log. I might want to get additional context. So we're going to use the same exact workflow that we did for the first use case, and that's to pivot on the community ID value. So I'm going to click the plus sign here. That's going to update my search up top. But because we're still limiting our search to the user agent, I'm going to remove that and rerun the search. And so now we get a few more logs here. We get, in addition to our Zeek HTTP log, we get a Zeek con log. Again, that's going to give us some kind of generic information about the flow, some GUIP information and things like that. So that's good context to have. But if we do have a network-based IDS alert, which we do in this case, well, let's take a look at it and see what it tells us. So let's drill into this alert. And so this is in the category of network Trojans. So this immediately makes me think this is even more suspicious than I previously might have been led to believe. And specifically, the rule name is in the emerging threats rule set. It's in the Trojan category, and it's for the Delphi Trojan downloader. So this gives me additional intelligence. This gives me additional confidence that this is something that is suspicious and is worthy of investigating, possibly worthy of engaging that incident response process. Finally, if we look at our Sysmon log down here, again, that's really going to tie things together, tying back to the host and ultimately tying back to the actual process that generated that traffic. So now we've kind of gone that full distance of pivoting from kind of our starting point, which in this case was an HTTP log, to getting additional context from an IDS alert, and then ultimately pinpointing that back to an actual process running on an actual endpoint. So that's use case number 3, or excuse me, that was use case number 2. So now for use case number 3, let's go the opposite direction. Let's start with endpoint logs, and let's work our way backwards towards the network logs, and let's tie them together that way. So in order to do that, I'm going to click this drop-down box. I'm going to go all the way to the top, and I'm going to pick this predefined query that we have that takes all of our events and groups by type, or event.module specifically. And so in this case, most of these data types are network-based data types, but I said for this use case, we want to start with endpoint logs. So let's drill into WinLogBeat, and you see in the data table in the bottom, I do have some IP addresses here. And so if you imagine that instead of having 884 logs, maybe I have 8,000 or 8 million or some large number where I don't want to go through these logs one by one by one. And so let's use the power of these group metrics to stack these logs and help us to do our job that much more quickly and easily. So let's say that maybe I want to group by source IP. So that's going to break that list down quite quickly for me, and I can say, well, maybe I'm really just interested in this one IP address, so I'll click the plus sign here, and that filters down to the .133 address. And then maybe I want to say, well, what are all the different IP addresses that this machine has connected to? So maybe I group also by destination IP. So now you see we've got this multi-group by where we're grouping by not only the event module and the source IP, but also the destination IP as well. And so I could start looking through this list for any IP addresses which might look interesting to me. So as I get towards kind of the long tail of that list, I do see this one IP address which does kind of look interesting to me. Now, if I don't immediately recognize that, I could do a little bit of open source research and I could find out that 8.8.8.8 is the Google DNS server. And you may be using this on your home network or perhaps in a lab network, but typically in an enterprise network, your endpoints are not going to be reaching out directly to Google's DNS server. They would most likely be configured to use an internal DNS server, and so whenever I see an internal workstation connecting out to a Google DNS server, that might be interesting, and I might want to investigate that. So let's click the plus sign here, and that narrows me down to one log. I've got one log coming from Sysmon that showed this Windows workstation connecting out to the Google DNS server, and we could get some information from that particular log. We looked before at the process executable field, which shows the actual process that generated that traffic. But I might want to get some additional context. I might want to look at this from the network perspective. So again, using the same workflow that we did before, we're going to pivot on the community ID value by clicking the plus sign here. We still have this other search criteria here, so we're simply going to remove that and rerun our search. And so now we've got multiple logs that match that community ID value. We were just looking at the Sysmon log down here, so now we'd like to look at our Zeek logs, and oh, by the way, we actually do have some network-based IDS alerts, which might give us some additional context. So we'll start with our Zeek con log. So drilling into the connection log, again, we see we do have some GeoIP information here. We have information about how many bytes, how many packets were in that particular flow. So that's good context to have. If I drill into the Zeek DNS log, I'm going to get some additional information like query name. And in this case, we see that the query name is a long random string of characters .onion. Now, if I didn't already know about the .onion domain name, I might do some research and find out that that's typically relating to Tor, the onion router. And so that might be interesting. And then I might want to continue further into these alerts. So let's drill into the first alert and see what we have here. And so this is a potential corporate privacy violation. That's kind of interesting. This is a DNS query for Tor hidden domain.onion, accessible via Tor. So that kind of confirms what we were suspecting in terms of that .onion domain name. And then finally, this last IDS alert is going to tell us that a network Trojan was detected. And so this particular content is actually seen in relation to the crypto wall Trojan. So now, using community ID, I've been able to pull together several different log types, correlate across several different log types, and paint a more complete picture about what actually happened in my enterprise. Now, one last thing that we'll take a look at, since we're talking about Sysmon logs, the latest release of Sysmon added a new feature which enables you to capture mark of the web information. So when a user downloads something from the internet, Windows creates an alternate data stream, which then stores this mark of the web information, and Sysmon, in its latest release, can now capture that. And so that gives you the capability of seeing where the user downloaded the file from and that additional context. That comes in really handy, especially in cases where maybe the download happened over HTTPS or some other form of encryption where our network visibility might not have a complete picture of what actually happened, and we might then need to look at that sort of endpoint logging. So let's see if we can find an example of that. So I'm going to go again to star group by event.module, and I'm going to look at WinLogBeat, and then I'm going to drill into one of these, and I'm looking for this field called event.action. And this is where we're going to find out what kind of really Sysmon data log this is. And so I could click the icon to the left of event.action, and that's going to add it to my group bys here, and then update my group metrics here. And so you see that we're now doing a multiple group by. Event.module is WinLogBeat, but event.action is where things get interesting. This is where I see the different types of Sysmon events that I have. And this new version of Sysmon is going to give us this file create stream hash thing that we can drill into, and we can start to look at some examples. So we'll just drill into this first example here. And what we're seeing in this case is actually a user downloading puttytail.exe, and this is coming from the Putty website, and it's being downloaded over HTTPS. And so I might not have full visibility in that from my standard Suricata and Zeek perspective, but because I have Sysmon on my endpoints and I'm collecting those logs in Security Onion, I'm able to then slice and dice those logs and figure out exactly where those downloads came from. So that's just a quick and simple kind of bonus use case using this latest release of Sysmon and our new Hunt interface. We do want to say thank you for tuning in to this YouTube video. If you are interested in things like training or professional services or our hardware appliances, please reach out to us at securityonionsolutions.com. We have contact information there, and we'll be glad to talk with you and figure out how we can help you to peel back the layers of your enterprise.